This video is for Chapter 8, Complex Designs for PSY 222, Research Methods in the Psychological Sciences. This is Part 2 of Chapter 8. So last time we were talking about a complex design involving two independent variables and a variety of dependent variables, and we had talked about how to think about the main effects. And that would be the separate impacts of the manipulation of the independent variables without thinking about their interactions. Now we're going to talk about how do we identify and then describe interaction effects in complex designs. Interaction effects, and I will say that of the ideas that you will learn in this class, this is one of the ones that you'll eventually have some kind of aha moment where you like, oh, now I get it. But it can be challenging, so be patient with yourself as you think it through. Finding visuals can help, so I'll try to use some of that as we're talking here. So interaction effects are described typically with a combination of just presenting the descriptive statistics. Now at the end of the Part 1 video, I showed you a couple of tables so that we could talk about the main effects. That's what they mean by presenting descriptive statistics, but you could also present that in graphical form. And often what researchers will do is to present line graphs so that you can have a visual way of seeing the interaction, and that's often represented in the form of non-parallel lines. So when you look at line graphs, you could have two separate groups and they're depicted with separate lines. A non-interaction would be when the lines are parallel to one another, and basically all you're seeing is a main effect. And then if though you have non-parallel lines, that would indicate an interaction effect. And you may remember my showing you a graphic that's an example of that earlier in Part 1 of this chapter. So interaction effects, then you have to confirm them. So you can visualize them in graphical form, again, most often in the form of a line graph. Then you have to use some inferential statistics to test whether what you're seeing is significant and worth exploring further. So graphs, figures, can be used to identify interaction effects that are potential, or you can look at the tables and kind of look at the means and imagine. But I like to use line graphs where you plot the means for the independent variable conditions, and you can look at it and say, okay, the lines aren't parallel. That means that an interaction is likely. So that would suggest that I need to do my inferential tests. You also may see lines that intersect, that converge, that diverge. Again, those are potential indications that you have an interaction effect of some kind. The test that you would use, the inferential statistical test that you would use to test for these effects, is something called an analysis of variance, or ANOVA, as it's often called. And that's going to help you identify both the significance level of the main effects and the interaction effects. I grabbed a screenshot from your text where you have what your authors are calling guidelines for the analysis of a two-factor experiment, and you're asking the question, is there an interaction effect that's likely to be significant? So if you are looking at the line graph and you think, yeah, that looks like an interaction effect to me, i.e. you have non-parallel lines on that line graph, then you have to look at the simple main effects to see if there's significance there. If there is, then you can compare those means further as a way of kind of detecting and elucidating the nature of those interaction effects. If you don't have simple main effects that are significant, then you stop. There's no need to do any further testing. whatever pattern you might be seeing in a line graph is probably an artifact. If you are looking at the graph and you don't think that there's an interaction, you can then ask the question directly, are the main effects for differences between groups significant? And you notice how this looks the same. So if you are eyeballing your line graph and you think that looks like an interaction, you ask the question, are the simple main effects significant? If they are, then you go ahead and you do the between groups comparisons across all of the conditions without collapsing for your independent variables. If you eyeball that line graph and think that doesn't look like an interaction to me, then you look specifically and only at the main effects. So going back to the example I was working with in video 1 for part 1 of the chapter, we're going to look for, and here they're giving you the difference between means, which is that subtraction method that your authors talk about. So you've got interrogator expectation, suspect status, those are your two independent variables. And we've already talked about some of the ways in which you look at the main effects. Now the DV that is represented by these numbers is the mean ratings of how hard the interrogator appears to be trying to get a confession. And I always like to start by kind of eyeballing. What do I see in these means? Well, down here, this looks like the highest one, right? So that's the people who were actually innocent, but the interrogator thought they were guilty. They exert what appears to be more effort than in any of the other three conditions. So even without plotting this, I can say these are not going to be parallel lines. So, and I can eyeball it and say, you know what, over here, these don't look too different. Here, those look different. And these numbers, that's the difference between the means. This number looks higher than this number. So what that suggests is that only in the condition where the interrogator expects guilt are we seeing a difference in terms of suspect status. It doesn't seem to matter when we have the interrogator expecting innocence. Now if we plot this out, and again these are the same numbers, and I went ahead and asked and built a graph, a line graph for you so that you could see what I mean by visually inspecting and looking at the lines. You remember enough of your grade school and high school math to know what parallel lines are. These are not parallel lines. And when the interrogator expected guilt, but the person was actually innocent, they exert more effort trying to get a confession than if the person was actually guilty. But over here, where they had an innocence expectation, it doesn't really matter whether they're guilty or not. You get roughly the same level of effort expended. Now when we look at this effect, and we're looking, because the next step in the analysis, is there a simple main effect of suspect status for the guilty expectation condition? So that means I want to compare this number with this number and find out, is there an actual significant difference in means within that condition? And just for completeness, you're going to run this test too, but this is the test you're really wanting to determine. Since there is an interaction effect, and it appears that this is the biggest difference, you're going to test for that simple main effect that's being driven by the expectation of guilt. Now that's in contrast to the non-significant main effect for suspect status for the innocent expectation condition. So again, I'm looking at the very same graph, and this time this is the means that I'm comparing for the simple main effect for suspect status, but only within the innocent expectation condition. So you have no significant difference here, but a significant difference here. Now with interaction effects, what these researchers inferred. So this is the point where you take the next set of steps. Casson et al., Casson and colleagues, argued that their findings supported what's called behavioral confirmation theory. The social psychologist in me says, yes, that's something that we call a self-fulfilling prophecy. If you expected guilt, you tend to behave in a way that's consistent with that expectation. Behavioral confirmation theory is kind of an extension offshoot of self-fulfilling prophecy. I pulled this quote: interrogator expectations triggered a range of behavioral confirmation effects, ultimately biasing perceptions of guilt, leading them to exert the most pressure on the actually innocent suspects, who you could guess argued their innocence quite ferociously. Now, interaction effects, you have to, as a part of your analysis procedure, you have to think about external validity. If an interaction effect is not present, you can then generalize across conditions. So if you find a non-significant interaction effect, then your focus is going to be on main effects of the independent variables separately, not as sort of a dynamic interaction. If you have an interaction effect, however, you still have limitations, and it sets the limits on when you can make those generalizations. So in the example that we were working with before, what we're talking about is you are only going to see that effect for confirmation bias under the conditions when people expect guilt. And that's when you see the interaction effect. It's not in the condition where innocence is expected. And that concludes part 2 of chapter 8.